In this video we will discuss about some mechanotransduction effect, how the stiffness changes the mechanotransduction effect within the cells. So our focus will be on FAK and the phosphorylation of these FAK forces. So in this video we will discuss how this FAK forces and its phosphorylations at this Y397 are linearly related to the forces. So in order to study these mechanotransductions, they have used this microfabricated post-array detector system. In this case, the zoom-in view is shown on the left-hand side of the panel, right-hand side of the panel A, where we can see that its vertical column is there, where the cells are adhered and then fixed and permeabilized, and then they check what are the forces it can triggers within the cells, and mainly their focus is on the FAK forces and how it changes with the different stiffness of this mPAD, that is microfabricated post-array detector system. So they use two different stiffness. Yeah. First one is this soft stiffness, which is around 5 kilopascal, and another one is this high stiffness, which is around 14 kilopascals. And they check this total FAKs using this dye, and the phosphorylated FAK using this dye, and then they check this vinsulin, which is the markers for EMT, using EGFP. And these are the post or the pillars, we can say that, of the microfabricated array. So for this FAK, and based on the deflection of these pillars, they are able to calculate the forces that are exerted, and in order to get these deflections they use the confocal microscopy. So for this total FAK, they can see that in the soft stiffness the less amount of traction forces are there, and phosphorylations FAK also less in the case of 5 kilopascals, and these are less compared to the case of this 14 kilopascals, where we can see the total FAKs are forces are higher, and also the phosphorylations forces are higher in those cases. And when they did the quantifications, and they can see that FA forces are lower in the panel J compared to the panel M, where we can see that for the control case FA forces are higher. And when they wanted to find out what is the reasons for this FAK forces, so they first knock out the ROCK inhibitors. First they use the ROCK inhibitors to suppress this ROCK pathway, which is known to trigger ectomycins, and when they inhibit this ROCK pathway they can see a decrease in the forces, indicating that ectomycins plays a role towards this FAK and FAK interactions. And also when they did their same studies in the higher stiffer surface, here also they see the same things, that is the FA. So this here also in the higher stiff surface also, when they inhibit the ROCK pathway they see a decrease in the FA forces. And they did the similar study, and apart from this ROCK inhibitors which triggers ectomycins, they also check whether the FAK kinase also affect this FA forces or not. But when they inhibit this kinase, when they inhibit the FAK kinase inhibitors, or when they use FAK kinase inhibitors, yeah, this is the right word, using this PF228, they do not see changes in the total forces, FA forces, and similarly for the stiffer surface also they do not see any changes. So this indicates that it's the ectomycins that plays a role towards this FAK, and this it plays a role towards this FAK focal adhesions, or this focal adhesions forces, not the FAK kinase. And they did their similar quantifications for the total FAK intensities and also the phosphorylated FAK intensities in both soft mPAD and stiff mPAD, and they can see the similar results for both the things. That is, when they use the ROCK inhibitors, the total FAK signals goes down for this, and also the phosphorylated FAK signal goes down, and this trend is similar for the soft mPAD and also for the stiffer mPAD and for the phosphorylate, but they do not see changes in the when they reduce when they use these ROCK inhibitors. Let me correct it. They see some significant changes that is mentioned by beta when they use the ROCK inhibitors also, and this is true for total FAK and phosphorylated FAK in soft mPAD and the stiff mPAD. Thereafter, they wanted to see whether there is a relationship between force that is exerted and also this total FAK that is triggered in the cells, and also this phosphorylated FAK that is present within the cells. And for the softer mPADs, they are not able to find any relationship, but for the stiffer mPAD, they can see a linear relationship, that is, with increase in force, they see a total increase in the FAK intensity and total increase in and also the increase in the phosphorylated Y397. This indicates that with the stiffer matrix, they are linearly related. FAK and phosphorylated Y397 forces intensities are linearly related to the forces, but this is not the case for the softer matrix. So, and this is also in line with the previously published results that FAK and phosphorylations of these FAKs are higher in the case of stiffer matrices or compared to the soft matrices. So this is what they just reiterate the results that are published in previously in order to validate that their microfabricated post array detector systems protocol is working properly. So that's all for this video. If you need to understand more about this mechanotransduction effects on soft and stiffer matrices, you can go through the reference that has been provided in the description. That's all for this video. Thank you for your time.